All right. Thanks so much for coming to H2O World. Thanks to Kuba for all his work in putting together these pipelines, these deployment scenarios. We understand that lots of people are questioning how we do this, right? It's not, we don't provide a lot of materials, but we're trying our best to give you the answers that you're asking for. So if you have questions about driverless, how do you deploy it? What kind of stuff do you even produce? Is it just Java, or is it also C++ or Python? Answers are all yes. We are listening to you. We're trying our best to give you all the features that you've been asking for months, sometimes years. And the roadmap is growing quickly. This is a small font because there's a lot of features, and I had to even crop some stuff out. But there is a lot of us listening to you. The company is growing, and there's more and more people involved in keeping customers happy. So if you have features that you want a specific loss function, or you want to know how to balance the true positives and the true negatives, or you want to deploy it in an embedded device somewhere, or you want to train it on CPUs and not GPUs, obviously that already works, but sometimes people still ask, right, how do we do this? Ask us, talk to us, and we are listening. So in the last few months, we've released version 1.3, 1.4, and 1.5 every few months or so. In 1.5 that just came out this month, we have a couple of new additions, and I will go through all of them here in more detail so you can catch up with those. One is the model diagnostics page. So if you have a model and you did not have a test set at the time that you were training the model, you can still now score that model on a test set, and not only get predictions as in the past, but actually get scores. So if you have a target column in there, you could ask, well, how does it do, right? How is the model doing in production as it evolves? And you can keep measuring the performance of the model in the GUI, for example, inside of the tool. You don't need to do it outside by taking the raw predictions and then computing your own scores outside. Now you can do it in the tool. So you can get all these metrics and graphs, and you can click on each one of them, and it will zoom in, and it will show you more details. There's also a special mode for regression models where you have a residual plot, so the predicted value versus the error. Then there's checkpointing. Lots of people have said, well, what happens if I run an experiment and it's taking too long? I don't have a full day. I need to do something else in that box. I need to reboot it or something. In the past, you would lose everything, and now you don't. Now you actually get checkpoints every time there's an iteration in the algorithm. Every time a yellow point shows up on the left chart, there is a checkpoint written to disk. If the application starts again, even though you pull the power, for example, you start it again, it will say, oh, I already know for this data set that I need to do these kinds of features. So there's a feature brain that's installed by default in your installation. So that's not on the cloud. We don't see that data. That's your data only. It's local to you. And there is a little bit of logic that knows how to benefit from prior experiments. And you can also control it more specifically. You can say restart from exactly this experiment. For example, if you run the same data set 100 times, right? You might have 100 different experiments. They each have their last checkpoint. Now you start the 101st experiment. It will automatically say, which one is the best so far? Let me continue from here. Unless you specify which one you want, or unless you turn that feature off. So there's a feature brain level. It goes from 0 to 10. The more you turn a number up, the more aggressive it will be at using all the previous information. If you set it to 0, it will start from scratch. So you have full control over the amount of brain capacity of prior models. You can also say, make me another model with the same parameters, something I like a lot myself. And we have Johnny in the house who implemented it. Hey, if you have questions about what else we could be doing, or suggestions, I should say, let us know. We're right here to hear. And I would say one other feature that's very important is to retrain the final pipeline. Sometimes people run an experiment for 2 days on big data, and then they realize that the accuracy settings was so high that the final model runs out of RAM because they're only a 64 gigabyte server or something. And we wanted to build a full model. Instead of reducing the quality of that final model we just die. Because we said you wanted to run with accuracy 8, we're going to run with accuracy 8. We're not going to suddenly run accuracy 2 just because you have no memory, because you launched a video game at the same time, right? Well, you probably wouldn't do that. But the point is that we will honor the settings. And if it doesn't work on your machine, it will die. What you then can do, you can say, OK, now run it again with settings 7 or 6. Or you put more memory in the machine, roughly speaking, and you do it a week later. But the state is still there. The same experiment, you can say, retrain final pipeline. It will remember all the features that we've trained, all the interactions, all the target encoding, one-hot encoding, and it will refit the final pipeline with the new settings that you have. So you can always control that, and you won't have to waste time retraining all the feature engineering. So there's two distinct stages. One is the feature engineering part, and one is the actual making of the final model. And you can configure whatever you want. Like the time control basically tells you how much feature engineering. And when you say retrain final pipeline, time goes to 0. We added several new data connectors in the last few months. And Nick is here, I think, somewhere that did a lot of this work. So thanks for that. We will add a JDBC database connector in the next release. It'll come. So you'll have all kinds of connectors that you could wish for. And we also added one-hot encoding. We had that feedback from a customer that said, anything that doesn't use one-hot encoding, I will not trust. And the truth is, it's true, right? It's a good feature to have, especially if you have low cardinality categoricals. So for example, you have cat, dog, or mouse. It's good to make it into 3 columns that say, am I cat, am I dog, or am I mouse? Yes or no, 0 or 1. And that's a good feature, especially for linear models, right? Because they need a separate coefficient for each of those predictors. So for linear models, we now make one-hot encoding features, and not just these rather advanced features of target encoding or so that they're a little bit hard to understand. So this makes more interpretable models. We also have a data splitter now in the tool, so you can import one massive data set, and then you can say split it. You don't need to do it outside of the tool anymore. And you can also import multiple files at once. If you haven't seen that yet, just click on multiple files and then say import. They all come in as separate files. We drastically improved the scalability in version 1.5. So data table, who here uses data table in their daily life? A few hands, not too many. So there is a Python version of data table that we open sourced, which has everything under the planet that you want for data manipulations, and it's a lot faster than other tools. And it's actually as fast as the R version of data table. And we use it for almost everything now in driverless AI. So it was co-developed with driverless AI because there was a need for faster data processing in Python. And all the group bys, aggregations, target encoding, numeric to categorical, all these transformations, usually group bys and aggregations are now done in data table. So it's 50 times faster and uses less than half the memory for this particular frequency encoding, which is just counting the group sizes. Oleksiy just joined us here. Hey. So he implemented the FTRL algorithm, which is follow the regularized leader. If you haven't heard of it, it's because Google kept it for it themselves, right? It's their ad-click algorithm. Node actually wrote a paper a few years ago, and the whole world said, oh, wow, that's pretty cool. It's based on hashing, so you can give any features, strings, numbers, doesn't matter. Whatever they give you, they hash that into a number, and then modulo it to like a size of vector that you have. And if whatever that vector in that element in the vector is not quite right to make the right predictions, you do almost like stochastic gradient descent or something on that vector, you know. So it's a simple algorithm, but you can have billions and billions of coefficients. You can have interactions because you can take multiple columns and string concatenate them and then hash it. So anything you have, just throw it in, it will fit it basically. And this is now done in data table. And here you have a few lines of code that show how it's done. This is open source, it's super fast, super scalable, and it can be fit over and over again in a for loop, right? So you can have small batches of data. Even if you have 100 petabyte of data, you can do this in a for loop, and the state gets updated every time. So you can do endless scaling, basically. We will add this endless scalability to driverless as well. But you have to understand that when you import a data set, we kind of want to tell you what's the min, what's the max. We can't just say, oh, I don't know yet, there's 100 more petabytes. So the user experience wants to know the whole data set. But some users say, I don't want you to do that. I want you to just tell me the column types and the names, and then from then on just stream for the next 6 days and fit the model on 5 terabytes, right? And if you're interested in this big data recipe that's like Google's ad click, then let us know. We can make that happen. Autoviz got some more polish and improvements. It's now also using data table underneath for the aggregation, which turns the massive data set into something that Leland Wilkinson's smart Java logic can work with and then display. So this is a very cool improvement, and files that are 15 gigs or so take less than a minute to auto-base. We also have Rulefit models, and we recently improved them to be more scalable. Now, this is an example of the first 4 rules of some data set that I ran. I think this is Paribas. So the Rulefit model is taking the 3 leaves and putting an L1 regularized linear model on top of those to decide which of the 3 leaves are the best leaves to keep. And if you end up in one of those leaves, what does it mean? What's your weight that you're going to get towards your contribution for the final prediction? So let's say you have a bunch of rules like these, and for each rule you ask yourself, do I, as a row, do I get a yes or a no? If I get a no, nothing happens. If I get a yes, you match this rule, you get that coefficient added to your sum. And at the end, that's your prediction. So it's a very interpretable model. You can literally write it down on a piece of paper, and it's better than a linear model because it's interpretable and it's good, right, at the same time. So that's a pretty cool algorithm, and we would love your feedback. This is in 1.5.2 as well. And the expert settings, who here uses expert settings when they're doing driverless? Lots of people are actually forced to use expert settings because the 3 knobs still are not enough, right? Ideally, we would say, well, you know everything, you don't need to tell us anything about your data, but that's not really true and fair because domain experts will always know more than us. So we need you to control it a little bit. For example, you can say, I want you to look at my distribution shift and drop columns that are different between train and test, or I don't want you to do that. Or I want to say, only do it if the difference between train and test has an AUC of more than 0.9. If it's really, if I really have different features, where it's obvious kind of that I'm not in training but in testing. If the AUC is 0.6 in that model that has to decide whether it's train or test, then I really can't tell. So I'm not going to mess with those columns. So there's all these thresholds that you can set. You can enable the models. We have GBM, light GBM, so XGBoost, light GBM. We have random forest, GLM, TensorFlow, Rulefit, and FTRL models. And one other thing is we added the compliant mode of building a pipeline, which is good for regulated industries. So we get no interactions, just GLM models basically. Very little extra effort on top of the raw features, and we just make a linear model. And then you can deploy that and feel calm that you know that nothing crazy is going on. So some customers gave us that feedback. They don't want all this magic, right? We are addressing different markets in this horizontal play. It's a very, very broadly applicable tool. And we are filling in the aquarelle painting, I should say, that we cover all the spots that we can find on the canvas. So the louder you speak, the louder we will make changes. The automatic documentation by Megan, if she's here in the room, lots of people love that a lot. It's now a Word file, no longer a PDF or a Markdown file, so you can actually quickly see the output of it in a nice way in your favorite Word editor. And Hemen, also in the room somewhere, hopefully. He added the project workspaces in the recent months, and it's almost finished, so we exposed the alpha preview for that in the product. You can enable it via the configuration file. And if you do that, then you can list different experiments in a leaderboard. You can sort by different metrics or time or whatever you like, by accuracy, and you can then see the scores on test sets. So you can score them all on a given test set. You can say, hey, on this test set, how are my models doing? And of course, this then becomes a validation set because you're doing it multiple times and all that. So you shouldn't overfit and say, oh, this is the very best model. But you know what you're doing. You have to have data sets and you have to have models and you need to be able to score. So this can now do this. And you also can compare visually the output of those scoring runs, those metrics. So you can compare the actual versus predicted or the ROC curves and so on. For time series, there were some improvements both on the back-end side. So we can now handle more time series problems that have a little bit more irregularities in them. We can also do test time augmentation. So before, we would make a time series model, let's say today. We take the Mojo and we ship it on a Mars rover and it's gone. And then it has to make predictions in a year from now, and it will only know the data that it saw today during training. It will never know any new data. Even though you give it scoring data all the time, it just wouldn't remember it. Now you can give it a whole batch of test set data to score, and it will say, oh wow, there's a lot of labeled data in there that I have actual numbers for my target column. So I'm going to just update my lags based on that. And I now know that last week's value was so-and-so. So when it has to make predictions on the Mars surface, so to speak, it will say, oh, wow, I have all this new information, even though it was trained today, a year before it was deployed. So you can have self-updating models in production. And it's important to state that it will not change the model. It will be an ephemeral kind of effect. So every time you say predict on this batch, it makes that batch prediction smarter, but the next batch is the same as always. Like there's no contamination between batches. It's just the same batch itself learns from itself. So if you give it more and more data, with all the history you have, it will get better and better. But you do have to give more and more data every time you score. So we don't have a state where we say, fix up the model mojo, so to speak. That doesn't work yet. And it's also just in Python only right now. So for time series in the MLI GUI interface, what you're seeing on the screen, we can show the actuals versus predicted in the future, right? The white line is the actuals, and the yellow line is, the actual is yellow. The white line is the predicted. So the white line predicts something too low. It actually it says the sales price is negative, right? Or not? Is it negative? Yeah, I think so. It's like -3 or something. So it's garbage, right? That model is not good. Well, why is it predicting -3? Well, something is pulling it to the left. And that's the lag interaction of department store. So that's per this department and store of the weekly sales 45 weeks ago. So now we can go look for that store and say, 45 weeks ago, what happened? Oh, it was closed or something and that day. And that affects my prediction. Just because it was closed 45 weeks ago, why does it mean that it has to be now also not making as much sales? So you can debug your models visually. And for every department and every store, there's this tuple of 2 integers, right? Each one will give you one of these plots. So these are per group. So you can actually inspect every department and store combination, even though it was only one experiment that fitted all of them at once. And you get Shapley values at the bottom that literally add up together. If you sum them all up, you get the prediction. So it's a very interpretable way to debug the model. And there's a lot more that happened in the last few months. And in December, I was able to write this blog. And you can find that on the webpage, our webpage. So if you're interested in the makings of driverless and what are all the pieces, what else has been happening in the last few months, please go to H2O.ai/blog. And of course, docs. The docs are always there. If you have any suggestions, let us know. I send an email to Arno at H2O.ai. I don't care. I get 100 emails a day, and they're all spam. I wish it was you sending me an email. So if you can just tell us what you like, I will forward it to the relevant people, and we'll make it happen. So that's it. And I think if you have questions, now we may have 1 minute or so.
Please submit your questions on Slido. Yes. So you can see all the information is on the billboard right there. Right now we have one question. Arno, if you want, you can start answering whatever's there. And then...
Oh, this one. Oh, what's the limit for data size? Okay, so I have an 80 gigabyte data set on my home PC, and I'm running driverless on it. But of course, I might set it up the right way by setting the knobs and so on. So I'm not saying it will always run on 80 gigabytes on your machine, but it should. So I would say tens of gigabytes should be no problem. If you do it on a laptop, it takes 16 gigs of RAM, it's not going to work, right? So it's a question of your machine. Some of our customers are running 600 gigabyte data sets on a 2 terabyte memory machine. And we understand that not everybody has a 2 terabyte server, so maybe we will add the multi-node solution rather sooner than later, and we are actually working on that. So we will have the capability to train bigger data sets eventually in this distributed version of driverless. But I would say for the meantime, we are trying to make it more efficient because H2O-3 is compressed, columnar, is a smart store. You can train big models on a workstation. So we will just put H2O-3 into driverless. And that's on the very short-term roadmap because everything is already implemented. We just have to call it. So that is the first solution. The second solution is to do a distributed sparkling water backend where we have to implement those Scala transformers that then will munch the final model in a distributed fashion. But the experiment itself might still start on a single node, let's say, or on a smaller cluster to figure out what to do. So for example, you have a 10-node cluster to figure out what to do. And at the end, you get a script out that says, now this is the final fitting of the final pipeline on your 100 terabytes. And that script you can then put into the sparkling water cluster and say run. That would be the dream, right? That we come up with the final fit script and the code for it to actually do the fit, not just the scoring, but the actual fitting of the final pipeline. But what to do has to be figured out first. And that will be most likely for another year or so in the Pythonic driverless implementation.
So I think there's maybe enough time for one last question. I think the topmost one is probably good for Patrick Hall maybe to answer in the coming talk.
Oh, I see. Perfect. Yeah, so the report should contain as much information as possible. If something is missing, like feature importance and so on, we should add it. Great. Thanks a lot for your attention.